Hello everyone, welcome to today's presentation. I'm excited to have you here. Today we'll be exploring the fascinating topic of combustion and flame. The title of our session is Combustion and Flame. We'll cover the basics of how combustion works, the nature of flames, and their applications. So let's dive in and discover the science behind these powerful processes. Let's take a look at the contents of this presentation. We'll start with combustible substances, which are materials that can catch fire and burn easily. Then, we'll move on to understanding what combustion actually is, how it happens, and why it's important. Next, we'll see that air is essential for combustion to take place, as oxygen supports the burning process. We'll also discuss the necessary conditions for combustion, such as the right temperature and the presence of fuel and oxygen. Following that, we'll explore how we can control fire, methods to start it when needed and prevent it from spreading when it's dangerous. We'll examine the structure of a candle flame, which helps us understand the different zones involved in a flame. We'll also look at the ignition temperature, which is the minimum temperature required to start combustion. Moving on, we'll review the types of combustion, complete and incomplete, and how they differ. We'll then consider the calorific value of a fuel, meaning how much energy it releases when burned. We'll discuss various types of fuels and what characteristics make a good fuel, like high calorific value, ease of storage, and safety. Finally, we'll look at the harmful effects of burning fuels on the environment, such as pollution and global warming. All these points connect to give us a comprehensive understanding of how fuels work, how to manage fire safely, and the impact of our energy choices on the planet. Let's talk about combustible substances. These are materials that can burn in air, producing both heat and light. They're quite common in our daily lives and include things like wood, coal, and charcoal. You'll also find them in fuels such as kerosene, petrol, and diesel. Additionally, liquefied petroleum gas, or LPG, and compressed natural gas, known as CNG, are also classified as combustible substances. Recognizing these is crucial because they play a significant role in many industries and domestic settings, but they also pose fire risks if not handled properly. Understanding what counts as a combustible substance helps us better appreciate fire safety and prevention. Let's talk about combustion. Combustion is a chemical process where a substance reacts with oxygen and produces heat. This reaction is what we typically think of as burning. The substance that undergoes this process is called a combustible substance, or more commonly, fuel. You'll notice that during combustion, sometimes light is produced, either as a visible flame or just a glow. This is a key indicator of the process happening, and an important point to remember is that air, specifically the oxygen in the air, is essential for combustion to occur. Without oxygen, the process simply can't happen. Understanding combustion helps us grasp how energy is released in many everyday activities, from heating our homes to fueling engines. It's a fundamental concept that ties into the overall theme of energy transfer and chemical reactions. Now let's look at why air is necessary for burning. First, I will fix a lighted candle on the table and place a glass chimney over it, resting it on a few wooden blocks. This setup allows air to enter the chimney from below. When I observe the flame, you'll notice it burns steadily and brightly. Next, I remove the blocks so that the chimney sits directly on the table. As you watch the flame now, you'll see that it starts to flicker and eventually goes out. This happens because without the air entering from below, the flame cannot sustain itself. Finally, I put a glass plate over the chimney, sealing it completely. Observe what happens to the flame now. It quickly goes out because there's no air left inside for combustion. These simple experiments clearly show that air is essential for burning. Without air, a flame cannot continue. When air can freely enter, the flame burns brightly. When it can't, the flame goes out. This connects to the overall idea that combustion, or burning, depends on the presence of air. Let's talk about ignition temperature, which is a key concept in understanding fire safety. The ignition temperature is the minimum temperature at which a substance will catch fire and start burning. It's important to remember that if the temperature of a substance is below this point, it simply won't ignite. Different substances have different ignition temperatures, so some materials are easier to set on fire than others. For example, kerosene has a lower ignition temperature than wood, meaning it ignites more easily. Now, there are also substances with very low ignition temperatures that can catch fire very quickly with just a small flame. These are called inflammable substances. Think of petrol, alcohol, LPG, and CNG. They all fall into this category. Recognizing these differences is crucial for safety, especially when handling or storing various materials. Understanding ignition temperatures helps us prevent fires and handle inflammable substances with the right precautions, tying into the overall theme of fire safety awareness. Now let's talk about the conditions necessary for combustion. For a substance to actually burn, it needs a few key elements. First, it needs fuel. That's the material that will be consumed in the fire. Without fuel, there's simply nothing to burn. Next, air is essential because it supplies oxygen. Without oxygen, combustion cannot occur. It's what allows the chemical reaction to happen and sustain the fire. And finally, heat. You need enough heat to raise the temperature of the fuel beyond its ignition point. That initial spark or heat source is what starts the process, and once it's going, the other conditions keep the fire alive. So remember, without fuel, oxygen, and heat, combustion just can't happen. These are the fundamental conditions that must be present for fire to exist and continue. All right, let's talk about how we actually control fire. The key idea here is understanding the conditions that are necessary for fire to exist. These conditions are fuel, oxygen, and heat. If we want to put out a fire, we can do so by removing or disrupting any one of these elements. For example, a fire extinguisher works by cutting off the supply of air, or oxygen, which the fire needs to keep burning. Sometimes, it also lowers the temperature of the fuel itself, which helps stop the fire. So, controlling fire often involves either removing the fuel, reducing the oxygen supply, or cooling the heat below the ignition temperature. This understanding ties back to the broader theme of fire safety and prevention, showing us the practical ways we can manage and prevent dangerous fires. Now, let's talk about some common methods we use to control fires. First up is using water. Water is by far the most common fire extinguisher, and it's especially effective when dealing with fires involving materials like wood, paper, and other ordinary combustibles. But it's important to remember, water should not be used if electrical equipment is on fire, because water conducts electricity and can pose a serious risk of electric shock. Also, water isn't suitable for oil or petrol fires because these fuels float on water and can continue to burn even after being poured on. Next, we have using carbon dioxide. This method is particularly effective for fires caused by flammable liquids like oil and petrol, as well as electrical fires. Carbon dioxide works by being heavier than air, so it sinks down and covers the fire, cutting off the oxygen supply that the fire needs to keep burning. Because of this, it quickly extinguishes the flames. Carbon dioxide is stored under high pressure as a liquid in cylinders, and it's often generated near the fire using chemicals like baking soda or potassium bicarbonate. Both methods are essential tools in fire safety, but choosing the right one depends on the type of fire you're dealing with. Now, let's explore the main types of combustion. First, we have rapid combustion. This occurs when a substance burns quickly, producing heat and light, often with the help of external heat. A common example is burning LPG, which happens rapidly and releases energy almost instantly. Next, there's spontaneous combustion. This happens when a substance ignites on its own without any external heat source. For instance, phosphorus can burn spontaneously at room temperature, which is why handling certain chemicals requires caution. Finally, we have explosion. An explosion is a sudden and violent form of combustion, where a substance burns very rapidly, generating heat, light, and sound. Think of fireworks or crackers. You apply heat or pressure, and they explode, releasing a burst of energy in an instant. Understanding these types helps us see how different materials behave during combustion. which ties back to our overall theme of chemical reactions and energy release. Let's talk about the flame, which is essentially the zone where combustion happens. The flame appears when a substance vaporizes during burning, creating visible gases that ignite. For example, substances like kerosene and wax vaporize easily, so they produce flames when they burn. On the other hand, some materials like coal and charcoal don't vaporize during combustion, so they burn without producing a visible flame. Understanding these differences helps us grasp how various materials behave during burning, which ties into the overall theme of combustion processes and fire safety. Now let's take a closer look at the structure of a candle flame. A typical candle flame is divided into three main zones, each with distinct characteristics. First, we have the outer zone. This is where complete combustion of the fuel occurs, meaning the wax vapors are fully burned. You'll notice that this part of the flame appears blue, and it's actually the hottest region of the flame. Next, we move to the middle zone. Here, the combustion is only partial, so the wax vapors aren't fully burned yet. The flame in this zone appears yellow, and it's moderately hot. Finally, there's the inner zone. This is the innermost part of the flame, where unburned vapors of the fuel are still present. The color here tends to be black or dark, and this is actually the least hot part of the flame. Understanding these zones helps us see how combustion works in a candle flame and connects to the broader themes of energy transfer and chemical reactions we've been discussing. Fuels can be broadly classified into three main types, which helps us understand their different properties and uses. The first type is solid fuels, like wood, coal, and charcoal. These are traditional fuels that have been used for centuries, mainly for heating and cooking. They are generally easy to store and transport, but they also produce more pollution compared to other types. Next, we have liquid fuels, which include kerosene, petrol, and diesel. These are commonly used in vehicles, engines, and for heating purposes. Liquid fuels are quite convenient because they are easy to handle and burn efficiently, making them essential for transportation and industry. Finally, there are gaseous fuels, such as CNG, LPG, biogas, and hydrogen. Gases are increasingly popular because they burn cleanly and are highly efficient. They are used in household cooking, industrial processes, and even as alternative fuels for vehicles. Connecting this to our overall theme, understanding these different types of fuels helps us make better choices for energy use, considering factors like efficiency, convenience, and environmental impact. Each type plays a vital role in meeting our energy needs in various contexts. All right, let's talk about the main characteristics of a good fuel. First, it should be readily available, meaning it's easy to find and access when we need it. This is crucial because if fuel isn't available, it can disrupt our energy supply. Next, a good fuel burns at a moderate rate, not too fast, not too slow, so we can control the energy release efficiently. Cost is also a big factor. A good fuel should be inexpensive, making it practical for widespread use without putting too much strain on our resources. Additionally, it should produce a large amount of heat, which is what we actually need for heating, power, or other applications. Environmental impact is another key point. The ideal fuel doesn't cause pollution, meaning it produces minimal harmful emissions. This helps us protect the environment and maintain cleaner air. It should also be easy to store and transport, so we can handle it safely and efficiently without much hassle. Lastly, a good fuel shouldn't leave behind undesirable substances after combustion, as these can cause problems like corrosion or pollution. When we consider all these factors together, we see that choosing the right fuel is essential for sustainable and efficient energy use. This ties back to our overall goal of finding fuels that are effective, economical, and environmentally friendly. Let's talk about the calorific value of a fuel. This is essentially the amount of heat energy produced when 1 kilogram of a fuel is completely burned. It's important to note that this value is typically expressed in kilojoules per kilogram. Now, different fuels have different calorific values, which means some release more energy than others during combustion. For example, cow dung cakes have a calorific value ranging from 6,000 to 8,000 kilojoules per kilogram. Kerosene, on the other hand, has a much higher value at around 45,000 kilojoules per kilogram. Wood generally has a calorific value between 17,000 and 22,000 kilojoules per kilogram, while LPG and diesel are even higher, with values around 45,000 and 55,000 kilojoules respectively. It's interesting to see that among all these fuels, hydrogen stands out because it has the highest calorific value. In fact, hydrogen can release up to 150,000 kilojoules per kilogram, making it very energy-dense. Other fuels like biogas range from 35,000 to 40,000. Coal is between 25,000 and 33,000, and methane has a calorific value of about 50,000. Petrol and CNG both also have calorific values around 45,000 to 50,000 kilojoules per kilogram. Understanding these values helps us compare the energy efficiency of different fuels, which is crucial when choosing the right one for specific applications. It ties back to the overall theme of energy sources and their efficiency in powering our daily needs. Let's talk about some of the harmful effects that burning fuels can have on our environment. When we burn materials like wood, coal, or petroleum, they release tiny unburnt carbon particles into the air. These particles can be dangerous because they contribute to respiratory diseases such as asthma, affecting our health directly. Additionally, most fuels release carbon dioxide gas during combustion. This gas is a major driver of climate change because it traps heat in the atmosphere. As a result, we're seeing a rise in global temperatures, which leads to melting polar ice caps, rising sea levels, and even flooding in coastal regions. These changes threaten both human communities and natural ecosystems. Another critical point is incomplete combustion. When fuels don't burn fully, they produce carbon monoxide, a highly poisonous gas. Even small amounts can be deadly, making proper combustion essential for safety. Lastly, burning coal and petroleum releases sulfur and nitrogen oxides into the air. These gases dissolve in rainwater, forming acid rain. Acid rain can harm crops, degrade soil quality, and damage buildings and monuments. All of these effects highlight how our reliance on fossil fuels impacts the environment profoundly, emphasizing the importance of finding cleaner, sustainable energy sources.